We're going to look at the first panel on the subject of biomass and the acronym BiCRS. And I talked yesterday for IU fans and alumni, this is not the little five BiCRS. This is a different sort of BiCRS. This is biomass removal and storage. Whether it comes in the form of agriculture, cover crops, forest residue, municipal solid waste. This is one area that offers significant potential for Indiana. This is one of the big ones, and you may remember Dr. Petridge mentioned Indiana has the potential to capture 23 million tons of CO2 a year, and at an estimate, this is important, a cost of less than $100 per ton, and that came up yesterday in the cost of removal and reduction. But doing so obviously has an impact on land use and change. So we want to talk about that today. What's the risks and uncertainties in this? What's the role of government in programs to help advance the opportunities? And what's the private industry support in the region for there? So our next panel, great to have you here, and we'll turn it over to you. Our moderator will be Dr. Wen-Chin Lee, a mechanical engineer and energy policy staff scientist at Lawrence Livermore National Laboratory. She leads the Carbon Removal Technology Systems Analysis Group. As one of the lead authors of the Rhodes Report, her research interests are clean energy technologies, sustainability, and environmental economics. And also an Iowa State graduate. I want to please welcome Dr. Wen-Chin Lee.
Thank you so much. Hello? Okay, great. Thank you guys for joining us again today for discussing this, opportunities in Midwest using biomass for carbon removal and storage. I just want to say it's really nice to be back here for fall, not winter. I don't miss the winter. It reminds me of the PhD school days back in school. I probably spend a lot of more time in the labs than outside, but the fall in Midwest, it's stunning, and I'm glad to be back here in Midwest. So today, the panel, the format will be very similar to what we had yesterday, the panel that led by my colleagues Drew and Allegra. So basically, we're going to, start with our panelists, introduce their experiences, share their insights about this topic, and then we will, start with a few quick questions to initiate the conversation. But the most important thing here today is, we want to invite you guys to ask questions, join the conversation. That's the main goal for here today. All right. I have a couple quick slides before we jump into the presentation, the discussion. I want to just share a few very quick thoughts about BiCRS in general, and also highlight the opportunities for BiCRS in Indiana. Let me test this. Hopefully it'll work. Okay, great. Yeah. So like our JP, our lead author for this report, mentioned yesterday that we found in this report that biomass has a huge potential for United States to help us not only produce products we need, but also remove carbon. This is very, very important that what biomass role can play here in Indiana here or even Midwest. I'm pretty sure you guys heard a lot about bioenergy, biofuels production, because you guys do such a great job there. But what I want to point out here today is, biomass is definitely a clean energy resource, but also is the OG of captured carbon dioxide from the air. And the carbon that already captured and stored in the biomass is also tremendously useful for us. So if we could integrate some capture system just one step further above our biofuel production system or electricity or hydrogen production system for biomass, we could basically remove all the carbon that otherwise being released back to the air, to the underground. And that can help us achieve carbon removal through biomass. That's the general concept. We totally acknowledge that there might be some competing interest in what's the best way to use the biomass. Should we produce fuel, maximize that, or carbon? What I want to point out here is let's try to not split in the way of like we're fighting each other. Let's think more collaboratively. Think beyond, producing the product we need. What else can we get from these biomass systems? And in our report, we have compared around 27 different BiCRS pathways that can produce a wide variety of products. And what we have investigated is, if you could go from biomass to hydrogen and integrate carbon capture and storage, which is more like the bottom McKinsey plot, you can remove a lot of over 800 million tons of carbon dioxide per year on top of the hydrogen production and other products production. But if, folks will think, biofuel is a focus, we still need biofuel for the future, which is, top left McKinsey bar, which is showing that we could still produce that, but if we can integrate the carbon capture and storage system on top of it, even though we can remove less carbon than the hydrogen system, which is the bottom one, we can still achieve a very significant amount of carbon removal, like hundreds, millions of tons of carbon dioxide per year, which is, co-benefit. Why not doing that? Here in Indiana, JP yesterday have highlighted that Indiana is, actually pretty good for BiCRS because you guys have the two most important part. You guys have a lot of biomass. You guys also have a lot of low-cost, suitable geologic storage for carbon dioxide, where Sue is going to specifically talking about that in another panel in the afternoon. The plot here, the map here basically shows, what is the carbon removal potential we can get through biomass on a county basis for Indiana. As you can say that there's quite a bit of waste of biomass that we could utilize here, around 14 million tons per year. And the majority of them is agriculture residue, mostly corn stover, 65% of that. We have a little bit forest residue, a little bit municipal solid waste. Above, what the waste of biomass we had here, if we could utilize the marginal land, the land that's not in use right now, to try to produce more carbon crops like switchgrass, we can add another 2.2 million ton of switchgrass carbon crops production potential per year. All of those biomass adding up together can equal to up to 23 million ton carbon removal potential every year, which is quite significant, our MC mentioned this morning. So with all of that, hopefully we could, have a really productive conversation here because, we have a great panelist, great panel of experts from all different sectors of BiCRS. We have, more biomass policy-focused Mark. We also have the biorefinery, like Charm Industrial. We also have the carbon capture and storage Vault 44.01. You got to explain how you got the name. It's quite amazing. So yeah, with that, let's start the discussion. And I would, like you guys to maybe start with a little bit introduction of yourself and talk a little bit details of your experiences with BiCRS in your field, in your office. We'll start with Mark.
Okay, is this on? Okay, great. I'm Mark Ellis. I'm a technology manager in the Bioenergy Technologies Office at the U.S. Department of Energy. Our office is really focused on decarbonizing three pillars: the transportation sector, the agricultural sector, and industry. Most of our focus, though, is placed in the aviation sector. We're trying to really develop the feedstocks and the conversion processes so that we can develop sustainable aviation fuel. If you know about the Sustainable Aviation Fuel Grand Challenge, they have two volumetric goals. They have a 3 billion gallons by 2030 and a 35 billion gallons by 2050. If we are successful in getting to 35 billion gallons by 2050, that means that every drop of fuel in the U.S. on U.S. planes domestically will be sustainable aviation fuel. There'll be no more petroleum jet fuel. So that's we're really trying to decarbonize the entire aviation sector by 2050. In terms of bikers, we've done a little bit of work, but it's more in other parts of DOE that have taken a lead, especially in the fossil energy and carbon management office.
You guys sponsor this work, roads removal?
We
That's
did,
huge.
yeah. We provided some funding for that. My previous supervisor was instrumental. I think she was a reviewer for this report, Nicole Fitzgerald. So yeah. Oh, okay. Okay, today I just wanted to talk about the available biomass resources in the U.S. Wenjin talked about the Indiana one, but I just wanted to perhaps talk about the potentially available feedstocks that could be used for bioenergy and produce either biofuels, bioproducts, or used for storage, as presented in the billion-ton 23 report. Before I give the results, though, I just want to emphasize that these results are not predictions and they're not targets. We actually did a economic analysis, a free market analysis that actually showed which feedstocks would be competitive on each acre of land throughout the U.S. and which would, so it's actually an outcome of that modeling, of that free market modeling, rather than, that we set out to find 8 billion tons. We didn't have that initial framework. We let the modeling do the work for us, and it does show that the U.S. will have, and does have, over 1 billion tons of biomass. So just diving into the actual numbers, first up is the currently used for energy. And if you can see that, it's 342 million tons that we currently use. And most of that is for corn grain for ethanol, as well as wood, chips, and pellets for heat and power. In the next resource class, we talk about the near term. And these are resources that we could readily get our hands on pretty quickly and use. There's not a lot more to do than just kind of collect, pick up the sticks, basically, that are out there. So that adds another 350 million tons. So we could effectively double our current bioeconomy just by the near term. In the next 3 stack bars, then we're getting into having a mature market drive the expansion, especially of the energy crops, the dedicated energy crops like switchgrass and miscanthus, short rotation woody crops, oil seeds. And so what we're showing in the mature market low, which means that we're not expecting an annual yield increase in the yield of the dedicated energy crops, but just relying on their already large yield. We can, and also bringing in the ag residues and the forestry residues, that we can get up to 1.1 million, which is basically tripling our current bioeconomy. In the mature market medium, we are assuming a 1% yield increase per year over the years of the simulation on the dedicated energy crop. So that brings in an extra 100 million tons. So we're up to around 1.25 billion tons. And then for the mature market high, we then assume a 3% yield increase per year on the dedicated energy crops. And that really drives the expansion, and you can get up to 1.5 billion tons. Now, we also included an emerging category now, and that's mainly the microalgae and the micro and macro algae. You can see those costs are pretty high, so we'll be working in our algae group to try to de-risk and bring down those costs. But they have the potential of bringing in another 250 million tons. And so we're at 1.75 billion tons in the our last resource class. And I just want to reemphasize that these estimates included sustainability constraints as well as economic. You can see there's a price on each of those. So we really did not take the last bit of corn stover off the field. We didn't take the last tree in the forest. In fact, for the corn stover, we took only a third of the available. And for the woody biomass, even it was only like 1%. So it was a very small slice of what's really out there. And just to wrap up, so now that we know that we have the feedstocks, what BETO is really focused on is making sure that when we grow the feedstocks, that we try to do it with the lowest carbon intensity that we can. And so we're trying to adopt the NRCS Climate Smart Ag Practices, that's some are listed here. In our 2023 and 2024 funding opportunities, we have really encouraged the use of these practices. And most of them fall in the soil health category, trying to enhance soil carbon sequestration. A lot of the people either choose cover crops as their technology of choice. Others use biochar. And so we have projects on both that we're just starting. So it'll be really, really interesting to see how the two compare. But that will be a few years before I can report on that. But I think that's all that I have.
Great. Thank you, Mark, for providing like a really good overview of the biomass estimation from BETO. Our report definitely aligned most of them with the old one, and hopefully update with the new ones. Next, I'm going to invite Colleen. Colleen is the head of forestry and agriculture and forestry policy lead in charm industry. I have to say that 3 years ago when we started this report, we didn't really get a lot of data for the charm industry process, but we're glad to have you today here to talk to us about your company and what charm do for carbon removal using biomass.
Thank you so much. Good morning, everyone. First, I want to say thank you to the folks here in Indiana and the folks at our labs for convening this conversation. It's a really important conversation, and the tools that both of your offices have provided are very important to the private sector businesses that are working to enter this space. Charm Industrial is a BiCRS company, so we take biomass and we convert it into a carbon-rich bio-oil using a fast pyrolysis process. And then we have that carbon-rich oil that is not particularly good for energy. It has a high water content. But it is tuned, we tune our pyrolysis process to be optimal for our purposes, which is a high carbon content. And then we inject that into old oil and gas assets that are no longer being used for that previous purpose. And that provides a very stable format for storage. Bio-oil is denser than most everything in the subsurface, and so when it is injected, it sinks to the bottom of the formation, and then it polymerizes in place. So it gets, it stabilizes there and stays there. We have sort of scientific confidence that it is at least 1,000 years permanence, but all estimates would suggest that it's tens of thousands of years permanence once it goes down there. We're essentially reverse engineering oil creation and placement in the subsurface. We use a couple different types of biomass residuals that I spend a lot of time thinking about biomass residuals and where to source them and how to pick up sticks and all of that. And it's exciting work because it is both new work and it's also work where we have really strong, robust legacy industries that have a lot of expertise. The agriculture sector, the forest products sector, folks know how to, we're very fortunate that we are in a country and in a region where we have the expertise of so many years of farming and so many years of investment in research that has been translated out to the field, and then that knowledge translated back. We can't forget that is an underpinning of these models and the potential that the country has. So we use corn stover as one source of that biomass that carries carbon molecules. And then we also use biomass residuals, which could be thinnings from a forest project. Right now, we're using a lot of wildfire residuals that are being removed from national forests and other lands out west because the Forest Service and forest practitioners have determined that that is the ecologically appropriate treatment for that place. And so, folks are going in, harvesting those usually smaller trees, and a lot of times they are in an area that has so few utilization options that they can't, the wood doesn't pay its way out of the forest, as people like to say. You would have to subsidize the cost of the material being removed. And then the question is, where do you take it? Some of it can go to lumber mills, but there's really very small capacity out west for that. And so what we do is we work to we pay for that material, and we pyrolyze it. And our model is built on the getting the sticks out of the forest. It is quite expensive because it's low value material if it doesn't have a market, and also it's heavy and transportation is very expensive. And if anyone has worked in logistics, you know how hard it is to get trucks and hauling scheduled especially if it's a one-off, right? It's a difficult sector right now, and so CHARM has reversed that challenge by, instead of centralizing biomass processing, we have a mobile pyrolyzer that we take out to the biomass so that we condense it into the bio-oil, which is about a 10x reduction, and we drive away with the bio-oil. And that also allows us to support biomass processing in regions that don't have utilization and that are underserved by industry.
Great. Wow. Thanks for introducing how the whole BiCRS process works in CHARMS from supply chain to converging. That's quite intriguing. Next, I'm going to ask Hugh to talk about his company. Hugh is the Senior Vice President of Development of Vault 44.01. And I would love you to introduce why you get the name, like you talked to me this morning, and also your experiences about your company in this carbon removal field.
Good morning, everybody. And I think as the other panelists have referenced, thank you so much for the audience this morning. Thank you for having us all. And thank you for the robust discussion. A little bit about my background. I joined Vault 44.01 as a founding employee approximately 4 years ago. I like to say that we've been around since we didn't get paid, we paid each other, and now we work with a private equity sponsor out of Dallas. Vault 44.01, question that we're asked often is 44.01, what is that, right? So carbon capture and sequestration is a very technically driven industry. It's not new. It's actually been around since the 70s and 80s from a transportation perspective and have been sequestering CO2 safely and effectively since early in the 2000s. So 44.01 and Vault. Vault, we sequester CO2. A vault represents somewhere safe. You put things there, you don't want them to come out. And then 44.01, referencing the number of engineers, geologists, reservoir folks that work at our organization, is actually the molecular mass of carbon dioxide. It's one of the first questions we get from all stakeholders is, what does it mean? How did you get there? What is CCS, or carbon capture and sequestration? Carbon capture and sequestration, when we think about it just in a very simple form, from a capture perspective, we are taking CO2 that's currently emitted from an industrial facility, and we are compressing it into what is referred to as a supercritical state, and then we are injecting it deep subsurface, generally over 3,000 vertical feet deep. I like to reference when I'm in Indianapolis, the Salesforce Tower. It would be effectively if you stacked 4 Salesforce towers on top of each other. Between there, you have numerous layers of what we call sealing formations that assist in keeping CO2 from moving up. So at a high level, you are taking CO2 from a lot of cases, ethanol facilities, that's being emitted into the air. You compress it, you inject it down a wellbore deep into the subsurface for permanent sequestration. One of the questions we also often get is, how many facilities are doing this? Right now in the state of Indiana, the majority of ethanol facilities are pursuing or exploring carbon capture and sequestration. Why is that? Why don't they just continue to do what they're currently doing? There's a decarbonization component to it. If all of the ethanol facilities in the state of Indiana were successful in reaching carbon capture sequestration development, you'd be reducing annual emissions in the state by about 5 million tons per annum, right? To put that in, I think it's about 1.25 million internal combustion engines that would come off the road. I'm a fan of internal combustion engines, by the way, but just it's generally something that we're able to think of and allow people to have a little bit of scale. It makes ethanol facilities more competitive, could have an impact on prices for access to new markets, creation of sustainable aviation fuels, capital investment, job creation. So really there is a decarbonization component to carbon capture and sequestration. There's an economic development component to CCS, or carbon capture and sequestration. How do we think about the business? How do we engage the public? A big part of what I do for Vault, what I have a great team behind me that does at Vault, and I think this resonates across all CCS projects, is we think about it as a three-legged stool. All of these projects need an industrial partner. Our core business for Vault has been very centric to the Eastern Corn Belt, specifically in the state of Indiana, and ethanol. What else do you need? You need the technical wherewithal to properly identify geology suitable for sequestration, safety, making sure CO2 is going to stay where you want it to, and then the financial wherewithal to invest in and bring these projects to fruition. What is the third component that is consistent across all of these? It's stakeholder engagement, voluntary stakeholder engagement. You read a lot about what goes wrong more often than you read about what goes right. So how do we think about that? Well, I always like to tell, 4 years ago when we started the business, I could say this is how we're going to do things and this is the results we anticipate. What I can sit here today and speak to you about is that, we've had great voluntary participation. Our most advanced projects have over 95% voluntary participation. The question arose yesterday of, do you pay farmers? Do you pay growers? Absolutely. It is a commercial negotiation. But the first component that leads to great voluntary participation in our mind is listening to what communities and landowners have to say. And I think our results so far have spoken to that, of listening, and then also it's education and information. Our process in working with landowners usually takes 9 months to a year. The majority of that time is spent educating and informing, a lot like we're doing today as an entire panel and as an entire group here at Roads to Removal.
Great, thank you, Hugh. I personally learned a lot about carbon capture and storage because it is very important for bikers. Just talking with Hugh, so definitely grab him for the break to ask him more questions. I'm going to start with a few questions here and invite you to ask questions. Just raise your hand if you have any questions. I'm going to start probably with Mark. Mark, you have talked about the Bill and Town study that Beto office has put a lot of efforts on. I just wondering, are there any risks and uncertainties associated with biomass resources when you do that estimation, and how do you characterize those uncertainties?
Yeah, thank you. And I touched on that at the end in the beginning here, but the main risk and uncertainty is, just how much do you take off? And it's related to our level of sustainability constraints. If we relaxed or made the constraints tighter, we'd get totally different numbers. Yeah. And so, we really take a lot of care. We have a lot of information on each of those constraints, why we chose these. In fact, a lot of the ones that were used in the Billion Ton 23 report were ones that we vetted with stakeholders for the 2016 report. And so we used a lot of that same information, the same constraints, and just making sure that, we didn't, in the 2016 report, we got more criticism. It was mainly from, you always have people on either side, but mainly you have people saying you're taking too much. I actually had some this last time on 2023 that we could have taken more, which was almost refreshing. But that's where the main uncertainty and risk lie, is just on those constraints. And and each one we have constraints for how much woody biomass we can take out, how much corn stover, where, like for the woody, we don't harvest on steep slopes or wet areas. We don't build new roads in order to get that last tree in the forest. So we have a whole list of constraints. But again, if you either relax them or make them tighter, you get different numbers.
Yeah, that's great to know and hear, like you guys factor in that. I think for the Roads for More report, our bottom line is when we estimate the biomass, we want no impact on cropland change and also food production. That's our baseline. So it's great to hear you guys are thinking similar ways. I'm going to now, just come to Colleen, ask you a question about, CHARM has done a lot of job trying to involving forest residue owners to get you the biomass you needed. Are there any challenges around the process? And additionally, when you think about corn stover, which is also a big market for you guys, how CHARM going to plan to involve farmers to provide the corn stover you needed?
Thank you. Thank you for that question. I will sort of start at a big picture level, which is to say that those same questions and calculations you all are making about what is environmentally sustainable, what's appropriate, those are questions that we deal with day in and day out. And as this market is still emerging, one of the primary ways that companies like CHARM can make sure that we're sourcing in a way that is responsible and in a way that meets our values and is also meets the values of our customers is to work with a third party that sets standards. So in our case, we work with a firm called Isometric, and they have developed a protocol for geological sequestration of bio-oil, and also a module on biomass feedstock sourcing. So you can check out our rules that we follow online at their website, and you will see a lot of if this then that, because they have really taken a lot of care to figure out where the science is right now on appropriate levels of stover removal on appropriate or on certain lands, and questions about what does sustainable forestry mean. So there's lots of different details you can check out, but that framework is very important to us because it enables us to then work with another third party, a verifier, who will come in and look at those decisions we've made, look at every part of our process and the emissions that we say that we are, that we're tracking all of our emissions, and they come in and check out our accounting and make sure that that fits what we're saying. And then they present a report to Isometric, which then determines whether or not we should have a credit issued for the amount of carbon that we are saying that we're putting underground as a net removal. So once we have that net removal, that is our product. And so say all of that to say that the sourcing decisions matter a lot because it's part of that whole process. And ultimately, we're here to put carbon underground. So if we're not making choices that are net removal, we need to make different choices.
Yeah, great to hear that, Kling. And just want to add a little bit more there about sustainable biomass sourcing. There's actually a lot of work going on around that topic. I think the baseline is, I think yesterday someone mentioned in one of the panel talking about, agriculture residue is not free. Farmers need them to fertilize their soil, right? I just want to say, that's definitely under consideration, and a lot of people are working on that to say, how can we smartly sourcing corn stover but not affecting the soil fertility? There are a lot of studies about that. All right, Hugh. You have talked a little bit about, your projects and involvement with stakeholders, landowners. Could you elaborate a little bit more? When you develop your carbon capture and storage project, when you were involving, different stakeholders, landowners, what are the challenges? What are the most important things that you need to, address during the process?
How long do we have this morning?
I'm looking to Susan.
So, thank you for the question. I would say that some of the challenges are, first and foremost, one of the questions we get is, where are you going to develop your well? And, frankly, that is up to the individual landowners in the communities that we work in. Prior to meeting with landowners, we've done an extensive amount of diligence on the subsurface. So we have a very good understanding of, generally speaking, the homogeneity of the subsurface characteristics that allow for safe sequestration. And then it is working with the individual landowners to, A, listen to their needs, and the community members to listen, and then the education and information around CCS. How is it conducted? What is the cadence of operations? Frankly, how long do things take? I think one of the things that has been challenging that we like to speak with people about, in some of our first conversations is this going to happen tomorrow? And the answer is no, absolutely not. We go through the strictest classification of permitting from the Environmental Protection Agency. We will have a state process that we will also go through. And that process can be up to 3 years. Currently, we have a project that is pushing over 2 years at the EPA right now with our Class 6 permit. And frankly, it'll be another 8 to 9 months, we think, before we will receive a permit. So I think the biggest thing for us, though, has just been the reception of the communities we've been involved in. I hope that is because of the approach that we have taken. We have chosen to do our business and speak to people at coffee tables and at kitchen tables and in diners, and not trying to do things at the State House. We want to work with all of our regulators, both state, federal, and municipal. But really, it's been working with folks within respective communities so that they understand the projects, the environmental impact, the risk mitigants that are in place, and the progression of the projects.
Great. I don't have to remind you about this. We have Signal. We talked about it before this. Thanks, Hugh, for share the experiences of involving landowners and the challenge of CCS projects. Now, I think we want to open up to questions. If you have any questions, please raise your hand and join us for this conversation. Okay, here.
Okay. Got a question for the moderator. There was a map you show for Indiana CO2 removal. And then I'm looking at the pattern on that map. I'm trying to imagine what your most important driver because I see most of the county that tends to have highest removal tend to be more in the central western portion of the state. And then also I can see low CO2 removal in the southern portion of the state. I can imagine probably the southern portion of the state, the soil quality could be a factor. But when I go to east, central portion of Indiana, it's kind of low removal and it's kind of patchy. So I'm trying to imagine what the drivers for high removal and low removal in different portion of the state.
Yeah.
If you can elaborate, thanks you.
Yeah. Thank you for, I definitely could touch more details on this. So this carbon removal potential map is very dependent on your biomass amount in each county. So how we did this calculation to understand the carbon removal potential for each county is understand, first of all, how much biomass you have in that county, what type of biomass, and of course, you can convert your biomass in many different ways, and that could lead to different carbon removal potential. What we're showing here is the upper limit, which is converting your biomass to hydrogen or electricity and then capture your carbon and store them underground. So in that way, you are basically capturing like 90% of your biomass carbon and put them underground. So through that equation, you can say that the CDR potential here is directly related to how much biomass you're having and what type of biomass you're having here. In terms of like soil carbon, I think I missed a little bit when you talked about that, but we can catch up in the break. We didn't really, when we calculate the CDR potential, we didn't really think about the soil part. We're mainly talking about how much waste of biomass we can take, how much we can convert to product, how much carbon we could capture and put them underground. So that's how we get the CDR potential. Did that answer your question? Okay, cool. We can definitely catch up later more on this, yeah. Open up, okay, there's a question.
Hi, I have a question about underground carbon storage. So we've seen from things like fracking, which involve putting pressurized fluids into the earth, that can sometimes result in minor earthquakes. So I'm wondering about the stability of what you're putting into the ground and if the people living above it would experience anything like that.
So stick around at 1:15. There's going to be a great panel that I think is going to be able to dive more technically into your question. But I also don't like when panelists sit up here and say, wait for the next panel. So how can I talk about this? So, during our diligence process, what are we looking for? And I think sometimes it's important to recognize what we're not looking for, right? And the presence of faults and fractures is one of those things that we do a ton of diligence on, whether that is through utilization of publicly available, what we refer to as 2D seismic information, so subsurface mapping that has been conducted previously, proprietary acquisition of both 2D and 3D seismic alike. Because what we are ultimately looking for here is not only the sequestration zone in a lot of Indiana referred to as the Mount Simon Formation, we're looking for the presence of primary sealing formations, referred to commonly here as the Eau Claire Formation. And then we're looking for well penetrations or the absence of well penetrations that could create a natural man-made avenue for a leak. And then to your point and your question, we're looking for the presence and or absence of faulting or fractures. One of the great things about Indiana is you have robust geologic potential for sequestration. But generally speaking, you have a relatively quiet or non-complex subsurface. So it is something that not only is done as we look at our pre-project diligence, we also are wanting to monitor where our CO2 is during injection. And this is a big component of that very stringent Environmental Protection Agency Class 6 process for the identification of faults and fractures. We want to avoid more than anything, and therefore you should not see felt-induced seismicity. Stick around at 1:15.
And I will just add that Charms Bio Oil, as I mentioned, is a pretty different material than supercritical CO2. Supercritical is buoyant. Our bio-oil is denser than most everything, and so it is going to stay down. And we're looking, of course, to not induce seismicity in communities. But the really fortunate thing is that we are looking at old assets, and a lot of times those assets have an abundance of data related to the initial discovery of that material, and then also its operation over time. And so we are building on that data store.
Question, and you mentioned the sustainable sourcing of biomass, I think both for CHARM and for Department of Energy for Mark. And looking at the Indiana map, it seems like the darkest counties are probably the highest productive agriculture counties also, which has the highest production of, and probably the best land to grow crops in as well. So the question on, it seems like for some of the biomass, the next marginal acre of land that's growing, a crop might be better for biomass than the most productive land for growing crops. And so, I mean, if you think of a farmer that's going to convert, the farmer might be the one that says, they have less margin on their corn and soybeans right now compared to others in, say, Tippecanoe or Allen County. They might be better to convert, so they might actually be in some of the lighter shaded counties. So that's sort of sustainable sourcing and thinking of how we do that. And then second, on biomass coming from, previously agricultural land that may have been planted to forestry for purpose-grown forest crops. I think in some of the sustainability metrics, you can't convert that back to biomass without it being, not considered sustainable. So, it's like, how do we get the rules written correctly so that, it may have been farmland or pasture at some point 15, 20 years ago, planted to trees. Now I want to go in and harvest all the trees and plant it back to a biomass, and I don't think that counts as a sustainable sourcing. So sort of two questions just on, how do we get the rules right so that we can actually get more biomass?
Yeah, I could start, but in terms of the billion ton 23, I think there's a nice figure in there where, again, as I mentioned before, we were competing every crop against each other on every bit of land. And there's a map in the billion ton 23 in the Corn Belt region, and it shows that corn is king. Switchgrass, miscanthus, all these other crops can't compete against corn on those prime agricultural lands. But what you do see in that map is that it's on the margins of the Corn Belt, and that's where it's able to have a competitive advantage for those dedicated energy crops to come in. So I'm not sure if you want to add anything else on that.
Sure. These are really important questions. They are questions that will likely play out for the next several decades, and they're really place-based. And they are based on the choices that private land managers are making, especially on our working lands. CHARM's approach right now is to focus on the residuals that would otherwise rot or emit carbon back into the atmosphere, or be burned and emit back into the atmosphere within the next 15 years. So we are looking at stover, we're looking at very sort of small bits of wood, depending on what the decay rates are, depending largely on humidity in different regions of the country. So we're analyzing all of that on a source-by-source basis. So really looking at, this summer we contracted for some small diameter logs that didn't have a market, that were from a wildfire mitigation project, and that was 153 acres, I think. So it's a pretty narrow volume that we're doing each analysis for, and we're analyzing it based on are we contributing to land use change? It's one of our principles that we not do that. Some of the the criteria that are sort of best in class right now for thinking about sourcing on agricultural lands are to say, are we sourcing stover from land where there is a crop rotation? And if there is a crop rotation, we're not going to source from that land in a repeated way that would indicate a change in that rotation. There are some parts of the country that are growing corn on corn on corn, that they would have a different treatment under that assessment. And then we also have biochar as a byproduct of our process. And that is also an available option to go back on land, depending on the choices of that producer and the appropriateness for that field.
I just want to add one last thing about, the sustainable biomass sourcing is definitely a super important topic for bikers, and a lot of people are working on that. I have to say right now there's no one answer that everybody agrees. But in my mind, I think what we are trying to do here is we try to harvest the waste of biomass with the intention of not harming the existing land right now. We start with that, and we open up to explore opportunities about, those abandoned land that's not in use. Can we grow something like carbon crops to, help carbon removal? But I do think the sustainable biomass sourcing rules, the criteria, would evolving with time. Like, you can't just say, I set up a rule now without much experiences and say you have to follow that rule for the next 20 years. That's putting industry in a really, really hard place to really meet those rules. But I do think we have to keep revising and revisiting those criteria as our experience increases, as the bikers market evolves, because we probably face different problems like economic leakage in the future that we need to consider later on. Okay, I think we have another question, Peter?
Hi, can you all hear me? Okay, there, I can hear myself, so answer that question. Great panel so far. I think biomass is it is an interesting tool in our kit here, and it's something we danced around yesterday, and I think we're dancing around it a little bit today, and that is we don't want to conflate carbon removal with carbon reductions, because they have two very different objectives in our climate mitigation future. But biomass can be used in reductions. And I think fundamentally what it comes down to is, and I study direct air capture, so I look at biomass. I already did the capture part for free. It almost seems unfair. So you have an opportunity in a vast but limited resource to preserve the intrinsic carbon capture, carbon removal that already exists in that biomass. So the question really is, I don't think it's a fair question, but I want to kind of hear where you land on this. Should we be focusing on that carbon removal, or should we be paying attention to what a lot of communities says, which is you can use this for energy, and you can use this for nutrient cycling and many other co-benefits. I don't necessarily see them as co-benefits as much as transfer benefits from the removal space into the reduction space. So, get your thoughts on that.
Yeah, maybe I'll start. But certainly for the bioenergy technologies office, we certainly are wanting to use the biomass for either fuels, products, or or storage. But and especially with our mandate that we got from above to focus on the decarbonization of aviation and ag and industry, we really have to find innovative uses for biomass in order to decarbonize those sectors. And so again, like I mentioned earlier, we're really focused. We used to be focused on cellulosic ethanol for automotive, for gasoline additive. But now we shifted focus. We probably feel that light duty vehicle will be electrified, and so you won't need as much cellulosic ethanol there. So now we shifted focus to a sector that really needs to have decarbonization. That's the aviation sector. Now, one nice thing about, with the billion ton, if you actually, 1.5 billion tons, if you assume 55 gallons per ton, you can have over 70 billion gallons of fuel generated. That certainly fulfills the Sustainable Aviation Fuel Grand Challenge at $35 billion, but it also gives you leftover for to address the not so easy to electrify other sectors like the marine and heavy duty truck and things like that. So I guess from my standpoint, we're trying to use biomass for fuels and products and just try to hit these decarbonization targets.
So CHARM is actively researching options for utilizing our bio-oil for further processes. We're particularly interested in iron reforming, which is a process that currently uses a fossil fuel input, natural gas, to react in order to make the chemical transition to get the ore product transformed. Can you tell that I don't do ore transforming daily? But that chemical transformation requires, we need a feedstock that has the right chemical in it, and our bio-oil could be a replacement for some of the traditional feedstocks that are used. And then on top of that reaction creates CO2. So then you could capture that CO2 on top. So you would be adjusting the carbon use in the feedstock and then also capturing it on the back end. And that would result in a net negative input to steel. I also want to say CHARM, plants are great at doing what they do. I don't know that it's always completely free. It's certainly not free for us. We're paying producers for their material, and they have, often put in quite a lot of money and time and into that crop, if it's a crop. One of the cool things that we are able to do is we are truly just paying them for carbon in a bale of stover. We're buying it from them the way that we would, someone might buy a bushel of corn. That enables them to still pursue monetization of their own production efficiencies on their land. So when we're talking about how do you dial back the amount of emissions that it takes to do business, and then also how do you capture more carbon and remove that, right? Those are two different. One is like reducing the emissions that are part of your process, and that could be in things like planting a cover crop or in changing nutrient management practices, whatever that is. And then also, so we leave that to the NRCS folks, to the folks we heard from yesterday, and then we are just paying for the carbon. And instead of having that go back into the atmosphere or be burned as it is in some parts of the country, we are then putting that underground.
I think we're at time. I just want to add one more thing, Peter. I think that's a great question, and that's how I want to, basically start this conversation. I don't think there is a fight between mitigation and removal. As a lot of people are trying to, argue which one's more important. I want to say biomass actually has a luxury to do both, right? And we're not trying to answer what is the best use of biomass here in the Rose Remote study. What we want to do is we want to provide all the different perspectives to people, to that region, and they can make their own choices. And even for biomass to do biofuel production, to mostly focus on reduction, I think there is still additional value if you could capture those gases, carbon, that coming out while you're producing your biofuels, right? And remove them, put them underground. That's extra benefit. And that's what we want to show to folks here, to remind you biomass is a energy and carbon source. Both are important to us. So with that, I'm going to thank you folks here to join us and asking those great questions. And also thanks to our great panelists, provide their insights and experiences. Feel free to grab them for more questions if you didn't get a chance to ask during this panel. And thank you.
Thank you. Great panel. We are at our first break, and before we go, always like to share some things when they happen in front of you, and it helps with some context. So last week, the National FFA convention was in town. Over 70,000 attendees, I would imagine. So it's usually 50,000 or so students, the rest teachers and advisors and supporters. Part of that expo, they have an agri-science fair. And I went through that agri-science fair knowing that I was going to be here. And I thought, let me take a look at what would be, I think there were about 60, 70 posters in this agri-science fair. And so these are students that have competed at the state level and have been and are able to compete at the national level in different categories. I'm like, let me just see, what they're interested in and what they're competing in. And so here's just a handful, and this is all that I could find in those 60 plus. So one was on viability of alternative fuel sources for lowering carbon emissions. Bingo. The next one was effects of a biochar amendment to soil containing low density polyethylene microplastics on lettuce growth. The next one, what is the optimal concentration of biochar? But then it got, I chuckled, it's not funny, but this is interesting. So this is a conference on reducing and capturing carbon. And these two, this one was CO2 supplementation impacts on yield and attributes of lettuce in hydroponics. So they're talking about putting more carbon in to help for growth. And the second, the effects of increased CO2 on Z-maize plants. Again, so that's what, 5 or 6 out of 60 on this topic. So I know Livermore, I believe you have some education materials and that get into the classroom, but in many cases the pipeline, when you think about how much time it takes to get some of this stuff and technology going and these markets established, don't forget about the next generation, and we get to them and as students. So if you are out there, please think about that. So we're going to take a break until 10:30. We've got coffee and drinks are there. It's a record warm day here in Indiana for those who have out of state. I would encourage you maybe to step onto the patio that we enjoyed last night. It might be a bit breezy, but it's going to be warm. We'll come back in and we'll start again at 10:30. Thanks.